Now, we know that tangent is defined as sine x over cosine x. All right? So when we have a rational function, a fraction, and when you have a function in the denominator, whenever you have a variable in the denominator, you know that now you have to watch out for not letting that denominator go to 0. Because what happens when the denominator equals 0 to the entire function? It's undefined, and that's where you get your vertical asymptotes, right? So in this case, tangent is 0 when cosine of x is 0. Okay? And if we think about what cosine of x looks like, it's 0 at 0. Where else is it 0? I'm sorry, it's not 0 at 0. It's it's 0 at pi over 2, 3 pi over 2, 5 pi over 2, right? So if we look at the unit circle, here, cosine is equal to 1, but cosine is 0 here and here. So whether you talk about pi over 2 and 3 pi over 2, or if you're going in the other direction, negative pi over 2 and negative 3 pi over 2, those are where cosine is 0. That means at those points, okay, tangent of x is undefined at cosine of x equals 0, and at all those points, it has vertical asymptotes. So again, those points are x equals pi over 2, x equals 3 pi over 2, and so on and so forth. So now, if we start graphing the cosine, now look at the cosine I graphed up there. If I continue that on the left side, right, you'll see that it also hits 0 at negative pi over 2, and here at pi over 2. So between those 2 points, negative pi over 2 and pi over 2, we have a graph of the cosine. Now when we talk about tangent, tangent is going to be undefined at negative pi over 2 and pi over 2, and you're going to have a graph in between. So what is the length of that between negative pi over 2 to pi over 2? How many pi? It's 1 pi. That means the tangent is defined to have a period of 1 pi. All right? So whereas sine and cosine, we said had a period of 2 pi, for the tangent, the period is 1 pi.
So that defines the asymptote.
Right. And that, for sine and cosine, the period is 2 pi, and we start at 0, go to 2 pi. In this case, we don't start at 0. We start at negative 2 and go to negative pi over 2 and go to pi over 2. So that's how the tangent is defined. All right? We always want to stick close to the origin as much as we can. So negative pi over 2 to pi over 2. Now, the equation for the tangent looks similar to what we had before, right? You see that you've got your A, your B, your C, your D, and each of those mean that they have the same purpose in the equation. Okay? Now, how would we figure out where the asymptotes are then? Well, for the asymptotes, we have to solve the equation x equals negative pi over 2 and x equals pi over 2. That's where, right? So when we take, remember we always looked at bx plus c. We set it to negative pi over 2 and pi over 2, and that's where our asymptotes are. All right. To figure out the period then, for the sine or cosine, we do 2 pi over b. For the tangent, it's just going to be pi over b. All right. All right, so let's take an example, and let's talk about what happens when we have to adjust the period for the tangent function. Remember, we were solving an equation for an inequality for cosine, and it said we take bx plus c, and that had to be bounded between 0 and 2 pi. Well, in this case, the bx plus c has to go between negative pi over 2 and pi over 2. With the exception that here it's just inequality. It's just a less than, not a less than or equal to. So let's fix that.
Oh,
yeah. All right, so that's what we have to solve, and that pretty much gives us like our beginning and our end and then our asymptotes. Okay, let's take a look at this first equation here, tangent of 3x. All right, what would the period be for this one? Pi over 3. That's it. So the period is pi over 3. That means from the beginning, from one asymptote to the other asymptote, how much distance are we going to go? Pi over 3. All right? Now, let's take a look at asymptotes. What we're going to do is take 3x, and we're going to solve the inequality, negative pi over 2 less than 3x less than pi over 2. So let's go ahead and do that. Negative pi over 2. Okay? Let's divide everything by 3. So we get negative pi over 6 x pi over 6. So we're starting at negative pi over 6. We're ending at pi over 6. The distance, you realize that's pi over 3. And our asymptotes then are these endpoints here. So x is negative pi over 6. X is positive pi over 6. You can also write x equals plus or minus pi over 6 to save time. That's the grown-up way to do it. We like that way too. Yeah.
But if you graph more than one period, wouldn't you have more than 2 asymptotes?
Yes, you would have 3.
You would have, wouldn't you have 4 if you graph? No, wait, no, I'm wrong. They would share one.
3, yeah, that would share the middle one. Okay, so it's going to look the same as it did before. So look, negative pi over 6, and we go 1, 2, 3, 4 to pi over 6. And at those points, I have my asymptotes. All right. So let's label the very center, the midpoint is 0. And then I have negative pi over what? 12 and pi over 12. So I know where my y-axis is. It's right in the middle there. Okay, now, let's take a look at this. When the angle is 0, at x equals 0, right? I take 0 and I plug it into my equation. Tangent of 3 times 0, which is tangent of 0, which is 0. Okay, good. Now, let's do some analyzing here. When x is 0, that's what I just did. When x is 0, I just plugged it in. Now, this portion to the right, that's the area, that's the region where my angle is just increasing from 0. When I go on the unit circle and I begin to increase my angle from 0, which quadrant do I fall in? Here. 1. Okay? So this region here, that corresponds to quadrant 1 in our unit circle. All right? Now, look at the region to the left of it. This is where the angle is going into the negatives right after 0. So it's decreasing from 0, the negative angle. So from here, if I go into the negative angles, what quadrant am I going into? 4. So this part corresponds to quadrant 4. Now, here is a question for you. In quadrant 1, is tangent positive or negative? Positive. So here, at the first midpoint here, I have a point at positive 1. Why 1? Because A in front of the tangent is 1. All right? So it's 1. Now, in the left, where it corresponds to quadrant 4, is tangent positive or negative? Negative. Negative. So here it'll be at negative 1. Okay? Do you guys believe me or no?
I'm confused why you're putting that. Like, why is it quadrant 1 and 4 and why?
Okay.
Yeah.
Why not 2 and 3? Because where is this region? This is the region. This is the region, and I'll show you something else, and then it'll really hit home. This is the region when you're just increasing your angle from 0. On the unit circle, I can only go in one direction, and when I'm increasing into the positive, that's in my quadrant 1. Now let me show you something else, which was what I was going to do next anyway. Let me show you something else. You see that first point is pi over 12? Let's do this. Now, I don't do this first. I do the other one first, because in Precalc Honors, I don't want you to be plugging in points like you have no understanding of anything else. But let's just plug in points now. So y equals tangent 3 times x. What's x there? Pi over 12. So that's y equals tangent of what? What's 3 pi over 12?
Pi over 4.
Pi over 4. Where's pi over 4? Where's pi over 4? Quadrant 1. What's tangent of pi over 4? 1. Okay? Let's do the next point. Y equals tangent 3 times negative pi over 12. This is tangent negative pi over 4. What quadrant is that in? Fourth. What's tangent of negative pi over 4? Negative 1. Do you see how we did it?
Pi over 12 is the first.
We're not in any mode because we're solving these without a calculator. This is not going to be on the calculator portion. So we're in brain mode. Okay, let me graph this and I'll take your question, Adam. So once you do that, it's going to follow the asymptote and then this. So